Okay, so for this tutorial, I am going to show you what it means to solve a triangle. So solving a triangle essentially means that you should know the measurement of every angle and of every side. And in this case, obviously it's a right triangle. That's what we're working with our trig functions. We have one side and one angle given. So the first thing that we can do is pretty easy. We know that all angles of a triangle should add up to be 180 degrees. So because the right angle, we know that that's 90 degrees. We know that the other two angles together should also be 90 degrees, since these two would be 90 plus this one to be 180. So to find this angle A over here, if we want to find the measure of angle A, that's going to come from taking 90 minus 34, or you could think of that as 180 minus 90 minus 34. So 90 minus 34, if you want to type it in, you can. 90 minus 34, hopefully we would be able to do that anyways, but we would get 56 degrees. So 56 degrees for angle A. So we're partway there. We have all of our angles. The next thing we need to do is work on finding the sides. So let's just pick a side. It doesn't matter what side you want to solve for first. Let's say if I pick this side, I'm going to call it X. So if I'm going to solve for X, I can use truly either angle, 56 or 34. I usually just go with the given angle, just because if I happen to make a mistake finding this angle or something, chances are I'll get this side correct, as long as I use that given angle. So from the 34 degrees, this side over here would be opposite of that, and then this side would be the adjacent side, because we know over here we have our hypotenuse when we're talking from that 34 degrees. So opposite over adjacent, we could say that the tangent of 34 degrees equals x over 10.7. And now if we want to get x by itself, we'd have to multiply both sides by that 10.7. So these cancel out over here. That means 10.7 times the tangent of 34 would give us x. So 10.7 times the tangent of 34, and again, my degree mode is turned on, right? If I was in radians, my answer would be in radians, so you need to be careful about that, just making sure that you're always there. So let's quit out of that. Oops. 10.7 times the tangent of 34, if I hit enter, we get about 7.2. The more decimals we keep, obviously the more exact that it is, but in this case, X, or we could call it side AC, we know that that is going to be, let's go ahead, let's do the nearest hundredth, 7.22. Whoops, we're on the wrong paper there, 7.22 units. So if we know two sides of a right triangle, then that means that we could find that third side in two different ways. We could either use the Pythagorean theorem, because as soon as you have two sides of a right triangle, you can find that third, or you can go about using trig again. There's pros and cons to each. Trig, again, takes usually a little bit of work, but the nice thing about trig is that your answer is probably going to be more exact. If I were to use the Pythagorean theorem and I would use this amount, 7.22, I rounded that, right? So that means I'm using a non-exact answer to come up with another part of my problem to find this hypotenuse, which means my answer is going to be even less exact. So I'm going to go ahead and I'm actually just going to use the given information again. I'm going to use this 34 here. I'm going to use the 10.7, and I'm going to solve for this side. I'll call it y in this case. So in this case, I'm using the adjacent and the hypotenuse. So I could say that the cosine of 34 equals 10.7 over y. And remember, to solve for y, especially when it's in the denominator, it takes a little bit more time. You got to multiply both sides by y first to get it out of the denominator. So we have y times the cosine of 34 equals 10.7. And now to get y by itself, we would divide both sides by that cosine of 34. So y equals 10.7 divided by the cosine of 34. So 10.7 divided by the cosine of 34, and we get 12.91. 12.91. So y is approximately 12.91. And again, this was side AB, so if you want to label it that way as well, that's fine. So we had to find all this information. We ended up finding the measure of angle A was 56 degrees, so there's our missing angle. And then the two sides, side AC was 7.22 and side AB was 12.91. A quick little check, remember the largest side should be across from the largest angle. The smallest side should be across from the smallest angle. So the smallest angle here was 34, 7.22. If I check, that is smaller than the 10.7 and the 12.91. That's good. Our hypotenuse should be the longest, 12.91. So it looks like we did this okay. But like I said, it's up to you. You can go about doing this last side using trig again, or you can use a Pythagorean theorem. But my advice, if you're going to use a Pythagorean theorem, try to use as accurate as possible a side that you've already found. So like here, instead of the 7.22, maybe I would have used a few more decimals just to make it as accurate as possible.